for the matrix transformation questions, you need to look at page 4 in your formula booklet, and then you're given these two standard matrices. The first one is the anti-clockwise rotation. Notice anti-clockwise, and it's about the origin. And the second one is a reflection in the line y equals tan theta x. Okay, so tan theta is going to be the coefficient of x, sort of from the equation you're given. So when I'm writing down the matrices, I'm using this information on page 4 of the formula booklet. Okay, so T1, I'm given three transformations in here. T1 is a reflection in the line x plus y equals 0. So your first job here now is to rewrite that line so it resembles the y equals tan theta x. So take it over. So we go y equals minus x. So comparing the two lines, y equals minus x with y equals tan theta x, that now tells me that tan theta is going to equal minus 1. So I can now get my value of theta. If I shift tan minus 1, it's telling me that's minus 45 degrees. I like to use the angle between 0 and 360, so the next angle at minus 1, minus 45, add 180 on, so it's 135 degrees. So theta is 135 degrees. It'll work with a negative 45 as well in the matrix, but I like to keep the angle between 0 and 360. Okay, so T1 now then, I now substitute that theta equal 135 into the standard matrix here. So it's going to be cos 2 lots of 135 is 270, sine 270, sine 270 minus cos of 270. And the cos of 270, you should know it looking at the graph, but just to make sure, cos of 270 is 0, so that value is 0, and the negative cos 270 is 0. Sine 270, again, you should know it from the graph, but sine 270 is minus 1. So that's matrix T1. And T2 is a translation. So once I know it's a translation, that's going to be a 3 by 3 matrix. And the translation 3 by 3 matrix has the structure 1 0 0 1, 0 0 1, and then the translation vector is inserted in this right hand column here. So I'm adding 2 to the x, subtracting 1 from the y, so that's going to be 2 minus 1. And then T3 is a clockwise rotation through pi by 2 about the origin. Right, pi by 2 is 90, so I'm going 90 degrees clockwise. Remember in the booklet here, the angle here is anti-clockwise rotation. So if it's running through 90 degrees clockwise, then it'll be 270 degrees anti-clockwise. So in this standard matrix here, I'm going to be substituting in theta equal to 270 degrees. So that's going to be cos 270 minus sine 270, sine of 270, cos 270. And cos 270 we know is 0. And sine 270 is minus 1, so the minus sine 270 minus 1 is plus 1, and sine 270 here is minus 1. So there's your three matrices for T1, T2, T3, and I've been using, as I say, the standard information given to me on page 4 of the formula booklet. Okay, now then, what we want, it tells me the single transformation T is T1 followed by T2 followed by T3. So remember now, when we have the compound transformations, the first matrix that we use is always next to the coordinates, i.e. it's on the right hand side. So when I write down these matrices, T1 will be on the right, then T2 will be to the left of T1, and T3 will be the left of T2. Because I got this translation matrix here, 3 by 3, all these matrices now have to become 3 by 3. So rewriting these out then T1 will be 0, -1, -1, 0, and I surround this then with 0, 0, 1, 0, 0. T2 is okay, that's already a 3 by 3, and then T3, okay, put the 2 by 2 in the bottom left corner, and then we surround it with 0, 0, 1. Okay, now to find T, so it was T1 first, so T1 is going on the right hand side. T2 to the left of that. And T3 to the left of that. The order is very important. Now I need to multiply these out. Right, I can do it two ways. I can either multiply these two together first, put the answer to the left of the third one, or I can multiply these two first and put the answer to the right of the first one. So I'm going to do these two first, and then the answer will go to the left. This one, so to multiply the matrices, remember we go across and down. So it's nothing, 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 added together makes nothing. Now for this one, first row, second column, nothing, 1, nothing, added together makes 1. And cross and down here, nothing, -1, nothing, added together makes -1. The second row, -1, nothing, nothing, that's -1. And the next entry, across the second row, second column, nothing, nothing, nothing. This entry across down, so it's -2, nothing, nothing, it's -2. And finally third row, first column, nothing, nothing, nothing. Second column, nothing, nothing, nothing. And finally the third column, nothing, nothing, 1. So then I need to multiply these out to get my answer to T. Again, it's going to be a 3 by 3 matrix. So we've got the first entry here, first row, first column, nothing, -1, nothing. Second column, nothing, nothing, nothing. And the third column, nothing, nothing, -1. And second row, first column, nothing, nothing, nothing. Second row, second column, 1, nothing, nothing. Third column, nothing, nothing, -2. And first column, nothing, nothing, nothing. Second column, nothing, nothing, nothing. And third column, nothing, nothing, 1. So there's compound transformation T, which is a combination of those 3 single transformations. And then part B is asking me to find the image under T of the line y equals 2x plus 1. So we've got T. T, and we want to find out what happens when I operate that matrix on that line. Now, the matrix, we can't do a matrix operation on a line, so we need to operate it on a point. So what I do, I get the parametric coordinates that would lie on this line. So I start off by putting x equal to t. Then if x is equal to t, substitute it in, then y is equal to 2t plus 1. So I'm operating this matrix on the coordinate t comma 2t plus 1. So -1, 0, -1, 0, 1, -2, 0, 0, 1. Operating on this coordinate t 2t plus 1. Now then, because it's a 3 by 3, I need to add an entry into the column vector here. It's just putting a 1 in. It acts as a dummy. You need only the first two coordinates, and I put a 1 there. It won't affect the coordinates that come out. Then multiplying that out, it's going to be a 3 by 1, going across and down. So it's minus t, nothing, minus 1. So it becomes minus t minus 1. The second row is nothing, 2t plus 1 minus 2. So it's 2t plus 1 minus 2, and then the third row will just give me 1. So just tidying the algebra up, minus t minus 1. So the second row is 2t minus 1, 1. So my coordinates under this transformation have changed from t to t plus 1 to minus t minus 1, comma 2t minus 1, 1. So my x coordinate is minus t minus 1, and my y is 2t minus 1. So to get then the Cartesian equation, i.e. the equation in terms of y and x, I then eliminate t from these two equations to get a relationship involving just y and x. So I think the easiest one to do is from the first one. So rearranging this, bring the t to the left, take the x over, so the t is minus x minus 1, and then replace the t I see in the y with minus x minus 1. So y is equal to 2 bracket minus x minus 1 minus 1. So y is minus 2x minus 2 minus 1. So y is equal to minus 2x minus 3. And that's the image of the line under t.